Howdy. Some time ago I made my microwave experiments with pebbles I found. And it was very interesting, the stuff that happened in my microwave and things I was reading and stuff like that. It was like, or it's very interesting. Let me just share with you a part of this video. I will put a link below. You can check out the whole video. It is as sketchy as every video I've ever made. But this is not about entertainment or anything like that. If you want to watch fancy videos with music and nice cutting and stuff like that, go to watch them. But anyway, let's just have a quick listen into this.
Ukko swings a hammer, and finally we find, in a vein of familiar symbolism, that his skirt sparkles with fire, that his stockings are blue, and his shoes crimson colored.
Yes, let's get on with this a bit faster. Because I try to apply or find things in the real world which in a way correlate with each other in order to create a more coherent picture. In this video, I am talking about the possibility that geomagnetically induced currents heated up the stones or the rocks, the bedrocks, and it created flames and stuff like that.
I just pinned this to the screen in order to make some little comparison. The picture here is already some weeks old, as I have been at Outokumpu at the copper ore mine. And I noticed these red rocks. And as you...
Yes, the red rocks. And that's the microwave. One of those microwave experiments I made. There is a piece of the copper ore in the microwave, which is glowing. And it has small blue flames. Because sulfur, when it burns, it has a blue flame. Yeah, I'm a bit lazy. Let's just go on with this. And this, I thought, could be, in a way, the skirt of fire. And as you can see, it's in a microwave. And let's just go on with this to the end. In order to just show you how this actually looked.
Those very sketchy videos. But anyway, it took me a very long time now to get exactly that discharge event here. The skirt. Because it's very quickly happened. Maybe we just should watch.
Yeah, now you get the idea. It's rather quickly happening, the stuff there. And this was my thing, the pieces I stitched together, what I found, like, at the bottom of the copper mountain, you find the crimson colored stones and stuff like that. I recommend you to watch at least this video whole, and there's a whole playlist about finished copper and stuff like this. And today I was reading some news, and they were very interesting because they mentioned something I have been talking about in this video too. And as I read those news and watched the pictures, it made me think about that there might be another possibility about the same things, basically, I have been talking about in the previous video. It's from India Today, the news, and it was very fresh when I found that, or it found me. However it went, it doesn't matter. We met. Skies in Mongolia mysteriously turned blood red. Pictures show eerie phenomena. The occurrence of the rare celestial event has provided scientists with a unique opportunity to study the effects of solar storm at lower latitudes. Yeah, maybe if you have heard about this, I was thinking loudly about the possible influence of the actual constituency of CMEs. Yeah, a CME, a coronal mass ejection. There is billions of tons of material, let's say, flying towards Earth. It's not just radiation or waves or frequencies. No, it's matter. Coronal mass ejection. Mass, matter, stuff. Iron, aluminium, sulfur, calcium. You know? Not just waves. And of course, all these elements have their own electromagnetic properties. They are charged. And they get ionized and stuff like that. But anyway, let's go to that. Listen to the story. Listen to my sketchy reading. Look at that. That's creepy almost. The eerie red sky seen in Mongolia. Yeah, what a sight. There is just red. There is no green. There is no blue. Just red. In short, the skies seen in Mongolia wear a striking crimson hue. Like it is said in the Kalevala, crimson red shoes. Like I have produced in my microwave, because copper ore, after it has been in the microwave for some time, it turns crimson red. And I think it's the sulfur which gives the color. And sulfur is found in the solar wind. Sulfur is found in CMEs. Let's continue. Rarity caused the interaction of solar particles. Again, we are talking about mass or masses, stuff, particles. Its appearance is closely linked to periods of intense solar activity. In an extraordinary celestial display, the skies over Mongolia turned deep blood red as the country experienced one of the rarest aurora events on Friday and early Saturday. The intense coloration is attributed to the initial impact of a significant solar storm that collided with Earth, creating a spectacle that left onlookers in awe. The phenomenon known as aurora typically occurs closer to the poles and is often green in color. However, the auroras seen in Mongolia were of a striking crimson hue, a rarity caused by the interaction of solar particles with oxygen at high altitudes. Over 241 kilometers above the Earth's surface, where the atmosphere is much thinner. Now, this is somehow strange. 241 kilometers, I don't know where they did that get from. So where's the article? Read full story. Okay. Look at that. That's amazing. That's amazing. No green, just red. Yeah, a little joke. Anyway, this particular shade of red is considered the most uncommon color of the northern lights, or Aurora Borealis, and its appearance is closely linked to periods of intense solar activity. The ongoing solar storm responsible for this event was the result of multiple coronal mass ejections, CMEs, from the Sun, which occurred on November 27th. Yeah, but the one hit us just, you know, it's somehow strange because I thought the CME just hit later. So this was before this cannibal CME hitting. Maybe I'm wrong. I don't know. These CMEs send a barrage of high energy particles hurling towards Earth, with the first wave reaching our planet late on November 29th. The red auroras are the consequences of these solar particles, the stuffs, particles, colliding with oxygen molecules at higher altitudes. At such great heights, the density of oxygen is lower and the collisions occur less frequently, resulting in the emission of red light rather than the more common green. Yeah, just could probably think about that. If there's less oxygen or less density in the atmosphere up there, what would happen if these particles would hit straight to the surface of the Earth? Let's say Earth's magnetosphere gets so weak that it doesn't shield anymore. Because usually the auroras are probably some 80 to 100 kilometers above our head. It's not that much. This process is akin to the way neon lights operate, with excited gas atoms releasing photons of light when they return to their ground state. Yeah, what a color. Think of that. If this would happen over some densely populated areas, let's say in the Western world, you know what I mean? Yeah, I won't dive into that now too much. Anyway, historically, red auroras have been documented during some of the most powerful geomagnetic storms, such as the Coherent event of 1859, which remains the most intense solar storm on record. Yeah, maybe not. There has been some recent news about. There has been probably more of these. During that event, red auroras were reported as far south as the Caribbean and Mexico, with the skies so bright that birds began to sing, mistaking the illuminated night for morning. The occurrence of the red aurora in Mongolia has provided scientists with a new, unique opportunity to study the effects of solar storms at lower latitudes. While the night may be mesmerizing, it also serves as a reminder of the sun's immense power and the potential impact of solar weather on our technologically dependent society. Yeah, maybe much more. Maybe the copper ore and the sulfur here in Finland has its origin on Venus, or maybe even on the Sun, or Saturn. The iron ore might be from Mars. Yeah, there are many possibilities. As the solar cycle progresses towards its predicted peak in 2024, skywatchers can expect more such displays of auroral beauty, though few may rival the intensity and rarity of Mongolia's blood-red skies. So, The thing which made me think was not only this, the red color, and this very beautiful 3 in the sky. First time I see a number in nature. I don't know what that is. But no crimson colored sky. And in the video I showed you in the beginning, I'm talking about the skirt made of fire, the blue stockings, and crimson colored shoes. So now let's just imagine that this auroral display would be the crimson colored shoes. Then we probably would need something which would in a way represent the blue stockings. Let me show you what I think could be a possibility of what would represent the blue stockings. And for this we can go over, for example, to SciTech Daily. Genesis of bizarre blue lightning jetting into the stratosphere detected from International Space Station. Yeah, that's from above thunderclouds. But it, in a way, could represent the blue stockings. And that's from a space station. Maybe there could be this kind of skirt of fire, lightning in the sky, as most people haven't ever seen. Yeah, basically they are too low still. But who knows? Actually, I just noticed that this is Finland, Sweden, Norway. How funny that they just draw this on that specific location. Anyway, there has been a video somewhere here which I still wanted to show you. I think it's this one. Look at that. I think that's the real video. The blue stockings. And basically the auroras, they would be above this. This paper is an impressive highlight of the many new phenomena ASIM is observing above thunderstorms and shows that we still have so much to discover and learn about the universe. Yes. I just wanted to show you this because I found it interesting. Blue stockings, crimson colored shoes. Maybe this is one version of the blue stockings. And this is one version of the crimson colored shoes. I don't know. Maybe one of you knows. But that's interesting. Very nice to watch it. There's even a number. Whatever the case may be, there's a 3. Thanks. Bye.